All right, in the process of simplifying a distance equation, I can take a look at the way in which things fly. Now, if I have a pumpkin here and it is shot out of a cannon, it follows this path called a parabola. And I can break its velocity up into two components at every single point in the flight. So initially, the pumpkin is traveling at a very high velocity in the up direction and a very high velocity in the right direction. But then, if I pay attention to its velocity a little time later, the velocity starts to decrease, and this is due to gravity. Now, to be honest, scientists have established that the rate at which it decelerates is negative 9.8 meters per second squared. But in the x-axis, scientists have found that the velocity does not change that much. It continues at the same rate in the right direction as it always had. And Newton came up with a law that explained this, and it's called Newton's first law. It's called the law of inertia. And what it states is an object, including pumpkins, in motion tends to stay in motion unless acted upon by an outside force. So once we get the pumpkin moving towards the right at a particular velocity, that velocity doesn't change that much. If that is the case, we can say that the acceleration in the x-axis equals 0 meters per second squared. And once again, that's due to Newton's first law of inertia. Well, in order to simplify the velocity formula, which begins like this, velocity final equals velocity initial plus acceleration times time. Now if I do this in the x-axis, I can bring the acceleration in the x-axis equals 0 meters per second squared, and this is due to Newton's first law, the law of inertia. So if I start to rewrite this formula and replace what I know, velocity final in the x-axis equals velocity initial in the x-axis plus whatever the acceleration is, and in this case it's 0 because of Newton's first law, times time. And now if you take a look, this simplifies down to plus 0. In essence, which doesn't mean anything at all, you don't influence the formula, and I've simplified my formula to velocity final in the x equals velocity initial in the x.